we use these rhombuses?
No.
No, we didn't use those rhombuses.
Well, what did we try?
Well, we could try. But you know what? I'm not gonna try up here because it's so hard to manipulate. Maybe Josh, I'll have you try that when we get the blocks out. Tegan, how else could we do it?
Squares.
We did not use the squares. But Tegan, maybe when we get the blocks out, you can see if they work. We didn't use the squares. Madison, what else did we do?
I was going to say the same as TV.
Caddy, what's another way we did it?
We did trapezoid and 3 triangles.
Oh, so we could do a trapezoid and 3 triangles. Spin you around.
That one's working good.
Sometimes I'm good at it. Okay, that's one way. And was there another way? Morgan, what do you remember?
We did one rhombus, a triangle, and a trapezoid.
Good. Awesome. So, what would you say? Here's my question. What does this, or this, or this, or this, or this represent? What number does it represent? Tegan?
1 whole.
1 whole. Good. Each one of these are 1 whole, but it's a different way to show 1 whole. So I'm showing 1 whole instead of a whole hexagon. I'm showing it broken into parts, aren't I? I'm showing it broken into parts. I'm showing it broken into fractions. I'm breaking my whole into parts. Like taking a cookie that Zach gave us, or that Jack gave us. My whole cookie, and then breaking it into parts, right? Is it still a whole cookie if I put it together?
No.
Yes. Jack is devastated right now that I'm breaking his cookie. Is it still a whole cookie if we put all the pieces together?
Yes.
Yeah. So if we put all, that will be the one I give you, Ashlyn. If we put all the pieces together, it's still a whole. Okay? So if we know that, let's start with this one with the 2 trapezoids. If we know that it equals 1 whole, that hexagon equals 1 whole, how could we write a number sentence to show what these trapezoids equal? What could we say? I don't know if I stated that originally. What's another number sentence we could write using what these trapezoids represent? What do the trapezoids represent? 1/2. Morgan, what do you think?
For the number sentence, it could be 1/2 plus 1/2 equals a whole.
Oh, so we could say 1/2 plus 1/2 equals a whole. Yeah. You know what you just did right now? I won't. Morgan just did our sticky standard. Pretty cool? I can break apart a fraction into the sum of smaller fractions with like denominators. So you took 1, and 1 wasn't really written as a fraction, but it could be. But you broke it apart into 2 fractions. We call that, guys, decomposing. So decomposing. I've heard that word before in science. Have you heard it before in science?
Yeah, it's where you take something and you reuse it, but like you're decomposing it.
You know what? I guess you could reuse it, but that's not. You're on the right track. But I want to be more specific, Caddy.
You break it down and it's like sometimes compost.
Yeah, break it down. Decompose means break it down. If I have a banana peel, I had a banana for lunch today, and I threw that banana peel into the garden. That banana peel, is it going to look the same in 2 days?
No.
In 5 days?
In a year.
Because it's going to actually break down and eventually become part of the soil. It's going to break down. So decompose, we're breaking down. We broke down our whole into 1/2 plus 1/2. How else can we break down a whole? Let's look at this model. How could we break down this whole? Coop,
1/3 plus 1/3 plus 1/3.
how did you get that?
Because I know that there can only be 3 trapezoids in the little thing.
Rhombuses.
Yeah, rounds.
Perfect. So 1/3 plus 1/3 plus 1/3 equals what? Ooh, who wants to try this one? I don't have them out the right way, but what do you think? I want more hands up. I need more choices. Eli, what do you think this one would be? This one. This messy one. What does this triangle represent, Eli? Whoops. What does this triangle represent? I know. I'm making a mess of it, aren't I?
Just put them all back.
Okay. How many total triangles are there, Eli?
Wait.
So each one would represent 1/6. So I could say, Eli, 1/6 plus equals what? Equals what? What do they equal when they're all together, Eli? Emma, how six? What? Three? Not three of them. How many of them?
6, 7, 6.
Yeah. So there's 6, 6, and another way to write that is 1. Yeah, they equal.
That's what I meant.
They equal one whole. Eli, when we put them all together, they equal a whole. If I put all the pieces of the cookie together, it equals a whole.
No,
No?
it was a hole.
Yeah, that's what I said, a whole. What about this one, Josh?
Triangle is 1/6, and the rhombus is 1/3,
Okay.
and
I don't get it.
the trapezoid is 1/2.
Good. And it equals.
No.
11.
Oh, I see how you got 11. You added up the denominator. But instead of doing it, because we never, ever add denominators, we'll talk about that in a couple weeks, actually next week. But instead, look, Josh, what does it represent? The third and the sixth and the whole? Oh, 1 whole. Yeah, it equals 1 whole. So, I'm not going to build another one. I want to actually show you another model. Let me pull this over. Oh, don't look. That's for my last class.
Don't look.
No cheating. No looking ahead.
I saw it.
Okay, so I am Emma going to draw a circle. And how many parts did I divide it into, Emma? How many parts did I divide it into? How many equal parts?
3. None.
3 equal parts?
4. 3, 4. 4. 3, 4. There's that.
Let Emma do it. How many equal parts are there, Emma, in the
4.
whole circle? 4. Good. How many did I shade in?
3.
3. So what
Stop
fraction?
telling.
Eli, let her do it. What fraction would it be?
Sorry.
Good. So Emma told me this represents 3/4. Okay? We're going to decompose 3/4, meaning we're going to break it apart. I could break it apart by saying this part plus this part plus this part. Couldn't I?
Yes.
It is. What is this part called? Josh?
1/4.
1/4. Good. What is this part called, Colin? What? 1/4. What is this part called? 1/4. And it equals.
What hole?
Does it?
No.
Because I didn't count this part. 3/4. Oh, okay. So we decomposed, or we broke apart 3/4. Miguel, have a seat. Like this. But I'm going to ask you guys to look at my fraction now. And look at these two
1/2.
fours together. Oh, Josh, what are they?
1/2.
What's another way I could decompose 3/4? I could say it's equal to
1/4.
1/2 plus.
1/4.
Oh, so I could also say 3/4 equals 1/2 plus 1/4, couldn't I?
It's not 1/4.
This part is, right?
Wow.
Here's my, but I combined them, right? I combined them to form a half. So I have 1/2 of the circle plus 1/4 of the circle equals 3/4. You know what we just did right now? And I know this is a long mini lesson, but we just did the second part of the sticky standard. Bridget's like, yeah. I can write number sentences to show fractions, that fractions can be separated in more than one way. Miguel, have a seat. We separated 3/4 in 2 different ways. Okay, so friends, today, I know I just threw this at you real quick, but today in Math Workshop, this is what we're going to be working on.
Yeah.
We're going to be working on, it's called decomposing, breaking apart fractions, and we're physically going to be breaking fractions apart. Here's how the rotations are going to work today.
Wait. Sorry.
Seahorses, you're going to work with me. You need to bring a pencil. Eli volunteered to get clipboards for everyone. Thank you, Eli. Very kind of you.
Okay.
Octopus, you're going to be playing fraction of in the library area. And eels, you're going to be working on a worksheet called Decomposing Fractions. Okay? You're going to try it. I know I just threw it out at you, but you're going to try it on your own right now. And you're also going to work on the IXL standards that you're at. It is Wednesday, so my computer assignments are as follows. Eli, you'll be on 1 because Brian's not here. Victoria 2, Madison 3, Richard's not here, he'll be on 4 if he comes back. Emma's on 5. Octopus, Tegan 1, Josh 2, Ashlyn and Bridget sharing 3. Miguel and Jack sharing 4. Morgan and Martez sharing 5. Eel, Talia 1, Ember 2, Drew and Colin are on 3. Patty and J. Marie 4, Zach and Cooper 5. All right, let's go ahead and get yours.
Do you want me to do it while you're in this group?
Yeah, so you can stop it now.
Okay.